Hey there guys, so we went for a fourth video after all, and I know I said yesterday, at least in most of the classes, that one of the reasons I want to use these video lectures is because I'll be able to tell you that I know cutting into your time to hang out with your friends, but we may have to do that a little bit, maybe, or in class as well, or on your phone, or on the bus, or whatever. But get these online, and that way I can say, hey, there's a 3-minute video that's the lab intro, or a 5-minute video that is, a concept we need for class tomorrow. And then instead of spending 20 minutes going over it in class and having to calm down the kids that pop up kind of like the whack-a-mole, if you've ever played that game. But every time you crush one of them down, another one pops up. And that's how it is with disobedient children in the classroom some kind. But what we're going to do is put some videos like lab introductions on the school server, tell you got to watch it at some point, and that you fill out a very simple little half sheet or a sheet, whatever, and that way you can show that to me. If you show up to class with it, you can do the lab. If you show up without it, we'll give you a bookwork for the day, and you can sit there and think about your poor decisions, all right? So today, our brief little experiment in this is that I need you to put together on a sheet with your name and date and the block that you're in. Always include the block. It's much easier on me. But your name, date, and block, you're going to put together a list of the things you need for the experiment tomorrow so that I don't have to explain it, all right? So tomorrow what we're going to be doing is learning a little bit about the probability, all right, probability of mixing certain types of parents. And we've done it in Punnett squares, but I want you to see it because obviously not everybody has 4 children that fit the exact match of a Punnett square. So maybe some of you are wondering why these Punnett squares supposedly represent children. So we're going to see tomorrow with probability a little bit how we do that. What you're going to need tomorrow is one tiny rubber coin, and you'll get this from the teacher. You can see it's 2 different colors, red on one side, white on the other. Some are red and yellow, but they're the same thing. You need one of these, and you're going to need one of these. And here's the trick. I'm actually going to say that you need 2 of each of these, okay? So you need 2 of the yellow coins, and you need 2 of the foam coins. So you should write that down on your sheet. You got the name, the block, the date. Write down 2 different, or 2 2-colored foam coins and 2 1-colored plastic coins. That's the easy step. The next step underneath there is to write down process. So the first one should be supplies, and you can just squeeze this in over the thing you just wrote down. And we've got 1, 2, the 2 supplies that you need we just talked about. Then procedure. That was a good spelling word for me. Procedure. I promise I'm a teacher. But procedure is going to be pretty simple also. For the procedure, we are going to be doing an experiment to show the different mixes. Now you can do a Punnett square, and you'll get a worksheet with exactly which parents to be using tomorrow. But your procedure should have 1, look at worksheet. So write down 1, look at worksheet. 2 will be follow instructions, but the brief part, or the brief explanation, is essentially we give you, or I give you, a set of parents, and if I say you have 2 heterogeneous parents, that means we're going to use these guys. Coins equal heterogeneous, or 2-colored coin equals heterogeneous, and the yellow coin equals a homozygous, and the yellow coin is a homozygous, this is a heterozygous coin, and a homozygous coin. Alright? So when you have 2 parents that say are both heterozygous, you're going to use these 2 coins and flip them the number of times that it says to, and each time we'll mark down exactly what popped up. So if you flip these 2 coins, we give them a spin and they both land this way, you will mark homozygous recessive because they're white. If you flip them and they land this way, you would mark homozygous dominant because the worksheet will say that red is dominant. And if you flip them and they end up like this, you can put down heterozygous because we have 1 of each. And you'll see statistically how this results in the long run. If we flip a lot of these, Then we're going to find statistics. So, 1, read the worksheet. 2, follow the worksheet in terms of number of coin flipping and what type. And 3 is going to be to count them up and figure out the statistics. And I know that sounds pretty complicated, but if you count it up and at the end, and that would be a number of times, if we flip it, say, 20 times, and you have 6 that were both red, 4 that were both white, lowercase w, and the remaining 10 that are 1 red and 1 white. The statistics are not super hard to figure out on this. We would have 10 out of 20 would be 50%. 6 out of 20 would be 30%. And 4 out of 20 is going to be 20%. And you'll have calculators tomorrow and be able to figure out the statistics nice and quick. And I want you to keep in mind that all of this will happen after one concept that I have to teach tomorrow, because we're going to use a real lecture, but it will be fast, especially if you're well behaved, and then we can get around to playing with coins. So that was a pre-lab. I think it was an easier way to do it, and hopefully you actually focused and listened. And tomorrow you'll show up with your worksheet that's got supplies and procedure on it. Excellent. Have a good rest of the day. This has been Ken's video lecture.